I'm Neil, and today I'm going to be building an Octave Fuzz guitar effects pedal. I'm going to use the Build Your Own Clone kit, which you get from buildyourown.clone.com. It costs about $70, which is a lot cheaper than buying a commercial product, and you get the joy of building it yourself. So let's see how easy it is. So we start by taking the contents of the kit out. And we get the enclosure, the backing for the enclosure, and then a bag full of components. We have the electronic components, the circuit board, the Footswitch, potentiometers, the switch to turn the fuzz on and off, a battery clip, some knobs, some wire for connecting everything up, our input and output sockets, four screws for the back of the enclosure, the AC input, an LED, some little locking nut washers, and some feet for the bottom of the pedal. For the first few stages of the instructions are available at buildyourown.clone.com. For the first few stages, we're only interested in the electronic components and the circuit board. Now, we have a small transformer there, which we don't need just now. I like to get a little dish to put all the extra components in. These are the capacitors, which we don't need at the moment. Transistors, more capacitors, some diodes, another diode, some transistors, another capacitor. So we're just left with the resistors, which we're going to put in the circuit board. So we're left with a bundle of resistors and the circuit board. Now, each part of the circuit board where there's a resistor required, there's a value for the resistor, and on each resistor there's a series of colours, and these bands tell you what the value of the resistor is. Now, there are various tools online where you can type in the bands or type in the value of the resistor, so that you know what the value of the resistor is and where you put each resistor. What can be a bit more useful is to use a multimeter, or to double check by using the combination of the two. So there we have the 4700 ohm resistor. So we bend each of the legs and we put that where it says 4K7 up the top. The resistors, unlike some of the capacitors, aren't polarized, which means that they can go in any direction. So, to make things slightly easier, I've worked out the value of all the resistors and I've written them down beside their value. I can wipe this marker off this desk later, so make sure you can on your desk too, or use a piece of paper. So that's all the resistors in, and now we're ready to solder. So, once you've got your resistors in place the resistor side down so that all the legs are sticking out. you touch the soldering iron against the component leg, and then touch the solder against the component leg until it melts. So once you've got your resistors in place it resistor side down, then touch the soldering iron against the component, a little bit of solder, and that forms a join with the circuit board. You do that for each leg, then snip off the spare wire with some wire cutters. Then you want to do that for each resistor. It's quite good to start with the resistors if you've not soldered in a little while, because the circuit board isn't populated, so you've got plenty of room to get in about it and solder. So there you go, that's all the resistors in, and it all looks good at the back. Next we're going to put in the diodes. They are largely the same as the resistors, except they are polarised. So we've got two types of diodes. One is an IN 4001, which is the black one, goes at the bottom of the circuit board. And you need to line up the stripe, the silver stripe at the end of it, with the stripe on the circuit board, so that the leg with the stripe goes through the square hole, so that the positive and negative is going in the right direction. Then there's two glass germanium diodes, and you do the same with them. You have a black stripe, and the side with the black stripe is through the square hole. Next we're going to add the three non-polarising capacitors. Now these are particularly annoying because it can be quite difficult to know what their values are. You don't really get multimeters which tell you, and they tend to vary from kit to kit. But as I said, they're non-polarised, so you can put them in any way. The ceramic disc, which in my kit is an orange disc, goes in the 150 picofarads bit, so it says 150p on the board. Then there's a 1 nanofarad capacitor, which is a little yellow film capacitor, and it goes in there. And I have a red 100 nano farad capacitor, which goes in there. But once you've worked out where they go, it's just the same process as it was for the resistors and the diodes. Okay, so now we're going to put in the transistors. There are two MPS 6521s and one MPS 6523, and these are marked on the circuit board Now you put in the transistors, which is each got 3 legs, with the flat side lining up with the flat side on the circuit board. Now rather than bend the legs over to either side like you did with the resistor, sometimes it just is better to alternate them back and forward, and they'll stay in place a little bit easier. So that's the transistors in, soldered, and the legs clipped. So next we have the aluminium capacitors. We have 3 of one and 2 of another. Normally you would read the rating off the side, but we know that we have 3 of one size and 2 of another, and the 3 larger ones have larger circles on the circuit board, and the 2 smaller ones have smaller circles on the circuit board. These are polarized, so the long leg of the capacitor goes through the square hole, i.e. the positive terminal. So that's our capacitors in. Next we have the transformer. It's got 6 legs and there's a big P on it. Now the P lines up with the P on the circuit board. So we put the 6 legs through with the P's matching up. Okay, that's all the main components apart from the LED in the circuit board. We now put in the battery connector, and it has 2 little holes to stabilise it, and then we have to come back down and go into the actual connections. So now we're going to connect the DC connector, which has 2 positive terminals, 1 negative terminal, to the 2 positive terminals on the little lip at the end of the circuit board, and there's a negative terminal. Now, just to make things easier, I've prepared 3 bits of hookup wire, which are meant to be roughly 2 inches long, maybe a bit longer, and I'm going to solder them to the connector first before I put it into the enclosure. Now I'm going to put this in an enclosure before I attach it to the circuit board, because if not you won't be able to get it through this little hole. We're now going to put the toggle switch and the two potentiometers and the LED onto the circuit board, but we're not going to solder them because we have to put them in place first. At the top of each potentiometer is the rating for the potentiometer. So the 1000 ohm potentiometer goes there, and the 100k potentiometer goes there. So that's the volume and the intensity. Then we have the LED, which again has a long leg and a short leg. The long leg goes in the square hole, the short leg in the round hole, and then we have the switch. It doesn't matter which way the switch goes, but it goes in the centre where all three of those are. What we do then is we turn it round, and this bit can be quite frustrating, and we match it up with the holes in the enclosure so that we can work out where everything should be soldered. Oh, take away the wee tab with a pair of pliers from the bottom of each potentiometer. You might want to undo the screw and the washer because they're going on the other side. So after a lot of swearing, you should have it looking like this on the other side, at which point you can put the screws and washers on to keep it secure. Now that the tricky stage is over, you solder in all those components. Next, you install the 1/4 inch input and output jacks. So we take off the washers and bolts. So the input one is stereo, so it's more complicated, than the output one is mono. The soldering of the output one is quite easy because it just needs one wire. So what we'll do is use the hookup wire to prep a piece of wire which is going to go from the output sleeve to the output pin down there. I usually start with the most footery or hardest part of the circuit board to get to. So in this case it's down here. You want to make sure and get rid of that trailing wire from in there, so snip that off and make sure that it comes out of the enclosure. Now you can either fit in the jack so that it's stabilised, or you can solder it and then fit it in, which I'm doing at the moment. It's a case of slotting it into the hole in the enclosure. The input jack is slightly more complicated in that there's 3 wires required, but there's no reason why it should be any more difficult. Okay, the final component to install, one of the most footery, is the Footswitch. Now, we're going to prep it a little bit before we put it in the enclosure, because there is a wire which connects pin 2 to pin 9. It doesn't matter what. You might find it useful to use the enclosure as a stand for the Footswitch. Now between terminals 7 and 8 of the Footswitch, there's a piece of wire connects both of them. And they are so close together that you might want to just take one of the legs of the resistors that you cut off and make a wee piece of wire. So I've prepped 5 wee bits of wire, which should go in pins 1, 3, 4, 5 and 6. So there's one on number 1. Right, we now put the pedal into the enclosure so that we can fix it in place for wiring in our last wires.